In a previous lesson, we learned about the Pythagorean theorem. We learned that a squared plus b squared equals c squared, and we learned how to find missing sides of a right triangle. We were also able to use the Pythagorean theorem to prove if a triangle was indeed a right triangle using the converse of the theorem. Today we are going to use the Pythagorean theorem to help us solve real-world situations. So in this first situation, as you can see in the picture, we have a ladder leaning up against a building. Now, the ladder reaches 18 feet high up on the building. It is 8.7 feet 8.7 feet away from the base of the building. We want to know how long is the ladder. Well, believe it or not, we can use the same strategy we used in the previous lesson. We write out the Pythagorean theorem, which I have already done for you, and then we're going to assign some values. We're going to label our right triangle. So notice they kind of drew in the right triangle. Now, we know the longest side is the hypotenuse across from the right angle. In this case, it is the one that we do not know. The other two sides, A and B, can be labeled either way, but since we do know those, we can now solve this problem. After we have labeled the triangle, we can substitute the values in. So I know that A is 8.75. That's going to be squared. I know that B is 18, so that's going to be squared, and I do not know what C is. So now I simply take the steps to solve the problem. If I take 8.75 and square it, I'm going to get 76.5625. And then if I take 18 and square it, I get 324. And that should equal C squared. If I add those two together, I get 400.5625, and that is equal to C squared. So now I've got C squared, but I really want C. So what am I going to do? I'm going to take the square root of each side, so the square root of this side and the square root of that side, and we are going to get a number that is very close to 20. All right. Now, in fact, when we're dealing with numbers that are very close, we can actually use the equal sign that is actually a little squiggly. Okay. So it asked us to find the length of the ladder round to the nearest 10. So the length of this ladder round to the nearest 10th is going to be 20 feet. All right, let's look at another one. In this scenario, we have two airplanes, and we want to know how far away they are from each other, okay? Or how much higher one is than the other one. So what we can do is we can make a right triangle between the two airplanes. So as you can see, we know that the distance between the airplanes is, the direct distance is 12 miles. We know that if we form a triangle, there is the directly below the higher airplane over to the other plane is 10 miles. Now the question is, what is the height difference between the airplanes? Well, we can once again use the Pythagorean theorem because we were able to create a right triangle. Let's assign the values. I know the longest side is C. I already have B, so then 10 must be A. Now I have 10 squared plus B squared equals 12 squared. So I have 100 plus B squared equals 144. Now to get B by itself, I'm going to subtract 100 from both sides, and now I have B squared equals 44. That is nice, except that I'm interested in B, not B squared. So I take the square root of both sides, and I end up with B equals 6.6. Now remember, when we're dealing with square roots, the square root gives you a positive and a negative answer, okay? Because negative 6.6 times negative 6.6 would also get us 44. But in this real life scenario, we cannot have this negative distance. So the one plane is about 6.6 miles higher than the other plane. Okay, one more. This one is a little bit tricky because we're kind of getting into some three-dimensional thinking. So we have a pole in the ground, and this pole casts a shadow. So we know how tall the pole is. We know that the shadow is 7 feet long. So what are we asked to do here? What they're saying is they want to connect a wire from the top of the pole, okay, to the edge of the shadow, which is 7 feet long. So I'm going to have a line from the top of the pole right to there. So now if you've noticed what we've created, we have created a right triangle. So let me solve it the same way that I've solved the other ones. I know that the longest side here is going to be the hypotenuse. I know that the others are going to be A and B. I fill in my information, 7 squared plus 12 squared equals C squared. That means 49 plus 144 has to equal C squared. Well, 144 plus 49 is going to be 193. And then to find what C is, I take the square root of both sides, and C equals 13.9. So the length of the wire from the top of the pole to a point 7 feet away from the bottom of the pole is going to have to be 13.9 feet. 13.9 feet. Okay, so we've looked at several ways that we can use the Pythagorean theorem in a real life example. Now what I would like you to do is try the got it to see if you indeed understand these scenarios.